Hello, welcome. Let's try to solve another Leetcode problem. 1092, shortest common supersequence. So let's first try to understand what is the common super subsequence. So for this example, CABAC is going to be the shortest common subsequence because it has AB. So this is ABAC, and another is CAB. So this is the shortest. We're going to return this kind of a string. Yeah. So if we use C31, 32, and we are calculating the common subsequence or supersequence, basically it is a LCS pattern. So it means the longest common subsequence pattern. Let me just use this example to explain why we can solve it by using DP, longest common subsequence pattern. So for me, I will always prepare a padding. So the padding is this is empty and this is empty. So this is the CAB for the string 2 for the columns. And for the rows, it's going to be ABAC. So this is the ABAC. And for the empty string, basically this is a C because the longest common is C. And this is easier. This is CA and CAB. This is AAB, ABA, and ABAC. I think this is easier to get. Now we are going to check this value, and we are going to check the first value, this AC, and by using this value, definitely we can get the formula. After getting the formula, we can directly write the function to finish it. Yeah. So at this position, what is the possible result? Definitely we're going to compare this character with this character. Definitely there are two cases. They can be equal or they cannot be equal. But what if they are equal? So for example, if this character A, maybe this is also A, but what if they are equal? It means any of the characters, because they are equal, just plus the character before all of them. It means empty plus A, it's going to be a character A. So this character A, so this string A going to be the longest common subsequence of this A and this A. Yeah, but currently it is not A, it is C. This means they are not equal. So this is going to be the second case. So the second case is that we can choose either of them, but it's going to be here, this one and this one. If we choose A from here, it means this A would plus this C, so it's going to be AC. Another case is that if we choose about this one, yeah, if we choose this character C, so what is the possible result? So it's going to be this C plus this A, but either of them, no matter AC or CA, and definitely it is the possible result. Yeah. So this is by checking how can we solve the problem. And similarly for the next one, this A equals to this A. This means we can directly get it. This is C plus the A. So it's going to be CA. Now let's check the last one. So this is B and this is A. So A not equal to B. So if A not equal to B, we're going to get this CA and CAB. So for while we are taking this CA, it means the common ones is going to be up to here, up to these areas. Yeah. Now we need to plus a B. It's going to be CAB. This is one case. Another case is we can also take this one, CAB. Yeah, but we need to plus another A. It's going to be CABA, but that is longer. We need to get the shorter one because we need to get the shortest common super subsequence. It's going to be the CAB, going to be the final result. Yeah. Let me just copy the previous submitted code to prove this really works, but it's going to have memory issues. Yeah, and it is also normal, and it is also common that sometimes we're going to have the memory issues because this is O(n) square for the time, but while you are considering my code, I used the string. Definitely, I got all the strings inside my DP array, inside my f function. So this is I prepared a padding, and this is the initialization for the padding, and here is the main function if they are equal, and if they are equal, I'm gonna just plus the string. If they are not equal, I'm got the minimum. Yeah, I got the minimum length of the string. So this k equal to length. This is a lambda function. This means I've got a string of the final result. And this is okay for if the testing cases are not so much. Let me print out the F. You're gonna see what happens for it. Yeah, so you're gonna see we're gonna put all the strings inside the array. Definitely we're gonna have the memory issues because it is here 10 to the power of 6 times 10 to the power of 3, it's gonna be 10 to the power of 9. Yeah, so the memory gonna become 10 to the power of 9. Definitely we're gonna have the memory issues. Let me submit it to TAG. Yeah, as you can see, we cannot pass all the testing cases because we have the memory issues. Yeah, and this is also possible. Yeah, this is also the normal case. If we have the memory issues, we should try to find a solution. Because there will be multiple valid strings, we just need to find any one of them. Yeah, so this means we can use backtracking to go back, but we don't need to write the backtracking function. Let me explain it from here. Yeah, so the idea is that currently, according to our first running of the DP function, we get an array, and maybe we just get some random numbers for this array. I just prepare a few, maybe. Yeah, maybe this number is 5. The longest super subsequence is 5. Yeah, so I'm gonna compare this character here. Maybe this is a C, this is also C. Yeah, so this means if they are equal, definitely, if this character equals to this character, definitely I want to check this one. Yeah, because this is common, they are the same. Definitely I wanted to choose this one. This is according to my DP function. I've already calculated the result, and maybe so this is 4. Yeah, and if this character, maybe this is a B, and if this is another B, yeah, it's the same, another B, they are equal. Maybe I'm gonna go to this position. So go to this position. So here maybe gonna become 3, and I'm gonna continue to check like that. Let me just go back to find another example. Yeah, so if this is a B and maybe this is a A, this means if they are not equal, so I'm gonna check this number 4. I'm gonna use this number. This is my current number. Yeah, because I would always to get a step. 5 to 4, it is a step. It means I go downward to 1 step. It means 5 minus 1, it is 4. Now I want to find 3, but I don't need to check here because they are not equal. I cannot check this one. I have to check this side and that side. Yeah, maybe here is a 3, here or here is a 3, but I can choose either one of them. Maybe this is a 3 first, so I'm gonna go to this way. Yeah, because definitely if I cannot go diagonal this way, I have to go left. I have to go left or top. Otherwise, I cannot not go back to the top left corner. So maybe I go left like this way. Maybe I go left and maybe I go top until I go to the top. And then I can, reverse my answer to get the result. Maybe this is, for example, maybe this is CB, ACA. After that, I'm gonna just reverse it to get the final result. Yeah, but for my while check, I may stop earlier from the row or bottom, from the row or column. I have to deal with the edge cases, but I will write it inside the code. Yeah. Now it means for the memory exceeded cases, it is not possible. Now we are going to turn it into integer. We just need to calculate with numbers what is the longest common super subsequence. But it will not be a string inside of the DP array. It will be a number. So we're gonna turn it into a number. It's gonna be easy. We just turn this one to 1, and if they are not equal, I'm gonna turn this to 1. And this to 1, and also here this to 1. I don't need to use the lambda function to check. I definitely get an integer. Yeah. Now I get the DP. So let's just check what is inside of the DP. Let me just return an empty string and check what is inside of the DP to check what is if everything is okay. Yeah, because the longest is 5. So as you can see here, it is 5. It means our DP function basically it is okay. Yeah, now we want to go back to find the answer. So I'm gonna start from the on bottom right corner, it's going to be r minus 1 with c minus 1. And I'm going to prepare a result as my final result array. I'm going to prepare an array. Now I can check. So while r more than and equal to 1, this is because I prepared a padding. If I prepared a padding, that means I have to check this r more than and equal to 1 and c more than and equal to 1. Yeah. Now, first of all, I'm going to check the characters. So if string 1 with r minus 1, because I'm starting from this r minus 1, and I've also prepared a padding, so it must be r minus 1. It is the last character, for example, this character c, or this character b. Yeah. So if this one equal to string 2 with c minus 1, so if they are equal, so I can go to the top left corner, diagonal directions. So it's going to be the result. I need to append any one of them because they are equal. So it's going to be string 1, r minus 1, and then r minus 1 and c minus 1. This is my direction. So if another case, it's going to be the dp function. So if frc, maybe I need to go to the left. So what about if I go to the left? Let me first go top. So r minus 1, if it is equal to r minus 1 with c plus 1, it means there is a step I can go to the top. If I were to go to the top, then definitely I would to append the string 1 with this character first. Yeah. While I append it, now I can update the row. Else, it's the last case. It's going to be frc. Yeah. Else, it's the last case. It means this frc equal to frc minus 1 plus 1. Yeah. So it's going to be the result append with the string 2 with c minus 1. And also for the column, it's going to minus 1. It means I will go to the left side. So for the final return, I need to check because any one of them gonna stop earlier. Maybe this r equal to 0, for example, but this c may equal to 5 or 2, I don't know. So I have to check the final result. So for the string 1, it may go to r, and I need to plus string 2, because the sequence doesn't matter. I need to with c. And this is why, because here is c. Finally, c will minus 1. It means this one will go to c minus 1. So in Python, we can use a slice to let it go to this character c. Yeah, go to this number c. And finally, we're going to plus the reverse of the result. Yeah, so we're going to join them together. So this will be the final solution. And this one, maybe you didn't do this before, but this is a normal way to, like the backtracking, we just need to go back to find a solution. In this way, although we used some time, but we saved the memory, our memory becomes n squared, and the time complexity is also n squared because mainly it is in these areas, it is n squared. But from here, this areas, it is on time. Yeah. So the time complexity is on squared, and the space complexity is also on squared. So that is why it can pass. Yeah, now let me just run it to check if everything is okay. This is not okay. I have to check. Yeah, I get something wrong. It means my backtrack is wrong. Let me just have a check. So this is our C. If this is equal, so I need to take this this one and r minus 1, c minus 1. If this equal to r minus 1 to the top row, I'm gonna use plus the string 1. Yeah, it's plus 1, r minus 1, c minus 1. Yeah, I think because I forgot to reverse the result. Let me just reverse the result to have a check. So I need to reverse the result. Now let me check. Yeah, now as you can see it works. Now let me submit it to check if it can pass all testing cases. Yeah, as you can see, it passed all testing cases, and the speed is pretty fast. Yeah. So I think that's for today's code. And for this one, basically you need to use the longest common subsequence pattern to solve the problem. It is not so difficult. You just need to prepare any kind of two solutions. So one solution is that you're gonna prepare a table, because you're gonna prepare the tabulation for them. Another is you're gonna just prepare string like S1 and S2, and you're gonna analyze it like that. But basically any one is okay. Yeah, and then you should try to find how to go back. If you were to go back, definitely you need to start from the bottom right corner to go to the top left corner, and you should check the edge cases, and from where you need to stop, until you find an answer, and then you can just get to the final result. I think that's for today's question. Thank you for watching. See you next time.